Miss Caparis says I should say welcome to school. So here we are. You'll have to pause the video if you have things you need to write down. Chrisana or Demaria, just pause the video. Okay. So we're going to be working on multiplying radicals today. Make sure you've got your notes labeled positive it is not. We're going to start out by reviewing just what the distributive property is, and really you should have no troubles with this. So write these problems down, do them on your own. For the first one, it's just the distributive property of -3. So you'd get -3x, and then -3 times 7 is -21. Make sure that you have -21 and not +21. For the second one, you need to use double distributing though, because you have two terms that need to be multiplied by two terms. So you're going to multiply the 2x through both the x and the -3. So 2x times x is going to be 2x squared. 2x times -3 would be -6x. And again, make sure you have -6x and not plus. Once you've distributed the 2x, then you have to distribute the 4 to both the x and the -3. So you would get 4x positive, and then 4 times -3 would be -12. In the end, you do have to simplify to make sure that you get your like terms all simplified, and it needs to be in standard form. So your x squared term comes first, then you combine the x terms to get -2x. Remember when I said minus? You need to do that. -12. If you have any questions right now, you're going to have to ask each other because I'm not here. Next one. This is what we're actually going to get into today, where you're going to work on the distributive property that has radicals in it. So it has square roots within your problem. When you take -3 or square root of 3 and multiply by the square root of 12, you would end up with the square root of 36. So you multiply the radicands together and you get the square root of 36. Plus, then the square root of 3 times 4, how you write that is you write the whole number first. So it would be 4 square root 3. Square root 3 is kind of treated like the variable, so it comes second. Square root of 36 is 6, so we get 6 plus 4 square root 3. Now I feel like I need to wait for somebody to stop writing, but you're just going to have to pause it and I'm going to keep going. Same exact process here, except now we're going to distribute the square root of 3. Sorry, square root of 8. Square root of 8 times square root of 3 would be the square root of 24. Minus square root of 8 times 3 is -3 square root 8. You cannot leave your answers like this because both of these have perfect square numbers in them. Perfect square number that goes into 24 would be 4. So I'm going to rewrite that as 4 times 6 minus 3. And then 8 also has a 4 in it. That's 4 times 2. Take out the square root of 4 and you would get 2 square root 6 minus square root of 4 is going to come out as a 2. So 3 times 2 would become 6 square root 2. And then that would be the answer. Always make sure that your square roots are completely simplified, that they contain no perfect square numbers. Go ahead and write this problem down. And I would prefer if you could pause the video right now, have everybody go through it, and then start it up with me going through it again. You'd end up with a square root of 49 minus 2 square root 7. This one gets completely simplified at the beginning because square root of 49 is 7. So it's 7 minus 2 square root 7. These cannot be added together because that has a radical. That one does not. They cannot be combined. Okay, now we're going to do double distributing when it contains radicals. It's going to be done just like we did with distributing, except we're distributing double the times. So square root of 4 times square root of 4. Multiply the radicands and you get 16. So that becomes a square root of 16. Square root of 4 times minus 6 is minus 6 square root 4. We've distributed the square root of 4, so now we'll distribute the 5. 5 times the square root of 4 is 5 square root 4. 5 times minus 6 is minus 30. Okay, we have a whole bunch of radicals that need to be simplified here. Square root of 16 is 4. Minus 6 times, instead of 6 times the square root of 4, we're going to write that as 6 times 2. Plus 5 times, and again, instead of the square root of 4, we'll write that as 2. Minus 30. So for this problem, we actually don't have any radicals left. Everything was a perfect square. So now you've got order of operations to go through. Multiplication needs to be done first. So we've got multiplication there, we've got multiplication there. And you don't have to go through this step by step. I know you are smart enough to figure this out. So 4 minus 12 is negative 8, plus 10 is 2, minus 30 is negative 28. So each one of these is going to get a little more complicated. Pause the video if you want to try to work through them as a class or whatever, and then turn this back on when you're ready to go through and check them. So 2 square root 3 times 6 square root 5. You multiply the whole number of parts and then you multiply the radicals. So 2 times 6 is going to be 12. And the square root part, the radicands are 3 and 5, so it's going to be 12 square root 15. Then we take 2 square root 3 times minus 4 square root 3. The whole numbers are 2 and negative 4, so that becomes negative 8. Square root 3 times square root 3 is going to become square root 9. We multiplied those radicands together. Then we'll distribute the square root of 5. This one doesn't have a whole number part, but don't forget this one does. So there's a 6, and then square root 5 times square root 5 is going to be square root 25. Then we'll multiply by the negative 4 square root 3. This one has a minus 4 whole part. Square root 5 times square root 3 is going to be square root 15. We got to simplify all the radicals that we can. 15 does not have a perfect square number that goes into it. The only numbers that go into it are 5 and 3, and they're not perfect squares. So I'll leave that as 12 square root 15 minus 8. Square root 9 is going to be 3, so that becomes 8 times 3, plus 6 times square root of 25, which is 5, so that's a whole number, 6 times 5, minus, and again, square root 15 is, you cannot simplify it or do anything with it. From there, we got to figure out multiplication parts of it, and then we'll have to combine our like terms. So we have 12 square root 15, change that to minus 24, change that to plus 30, minus 4 square root 15. Like terms are whole numbers can be combined together. The other thing that can be combined together are square roots that are identical. If the radicands are identical, you can add them together. So this becomes 12 minus 4. So when you combine those, you get 8 square root 15. Whoa. That's the combination of the square root 15 terms. And then you also have minus 24 plus 30, so that's plus 6. And those can't be added together because now they're not like terms. Any questions? Oh, good, I'm glad. Okay, this would be a good one for you to pause the video and have everybody work on their own for just a moment. When you're done, play the video so you can double check what you've got. We're going to have 7 times 7. Go ahead and write that as 49 right away. 7 times minus 3 square root 5. So 7 times minus 3 would give you minus 21. Don't forget the square root 5 that's after it. So the whole number parts get multiplied, but then you have the square root after it. When we multiply these, 3 times 7 is positive 21, but then we have the square root of 5 after that. When we multiply these, 3 times minus 3 is going to be minus 9. Square root of 5 times square root of 5 is square root of 25. Multiply the radicands together. So let's see what we can simplify. 5 cannot be simplified. You like that 5 in that square root? Very nicely drawn. We have another one. 21. Oh, there's supposed to be a 1 there. 21 square root 5 plus 21 square root 5. This is going to become minus 9, and then square root of 25 is just 5. So that becomes 9 times 5. We have a 49. Have you noticed that we have two like terms here? Both of these have square root 5s and they're opposites. So minus 21 plus 21 means those are going to go away completely. I still have this minus 45 at the end though. So the answer is 4. Hopefully you went through and some of you were able to get that answer. Okay, I'm not going to go through this whole problem, but I do want you to remember what squaring means. Squaring simply means take this and multiply it by itself. So we're going to have square root of 3 minus 4 times square root of 3 minus 4. So I'm going to have all of you work through that on your own with the video paused, and then together make sure everybody's got the same answer. So share with your partner, make sure everybody's got that. When you're done, start the video again. We have one more problem. The last problem is dealing with right triangles, and this is the right triangle, by the way. So go ahead and draw your right triangle. The base is going to be the square root of 2 plus the square root of 7. The height is the square root of 2 minus the square root of 7. And your job is to figure out what the hypotenuse is. Oh, whoa. Hypotenuse is going to be this side right over here. So I'm going to call it C since it's the C in the Pythagorean theorem. And we've got to plug all this into the Pythagorean theorem. A squared and B squared are going to be these two sides squared. So we will have the base. That's your A squared, the base squared. Plus you have the height squared. And that's all going to equal the hypotenuse squared, or C squared. This is going to be a mess. So I'm going to work through it. You're probably going to need to stop the video along the way to make sure you can get your notes taken. I'll rewrite each of these kind of the longhand way. And maybe we'll do them separately because I'm not going to have enough room to write it all out. So I'm just going to look at the square root of 2 plus the square root of 7 squared first, and we'll get that all simplified. Square root of 2 times the square root of 2 is square root of 7, or square root of 4, because 2 times 2 is 4. Square root of 2 times square root of 7 is going to be the square root of 14. Square root of 7 times the square root of 2 is going to be another square root of 14. And then the square root of 7 times the square root of 7 will be the square root of 49. We have two terms that are perfect squares and two terms that can be added together because these are the same. So this one's going to become a 2. Each of these have a 1 in front of them. So when you take this 1 plus this 1, I would get 2 square root 14 plus 7. And in the end, this becomes 9 plus 2 square root 14. So this right here is what that is equal to. So we're going to come back and put that in after we've simplified this second problem here. So now I'm going to write the second part out and see what that's equal to. not sure how I'm going to fit this all on the same screen here, so we'll see what I come up with. Double distribute here again, just like we did before, and it's the same exact numbers that you're multiplying, it's just that you have minus signs in here instead of plus signs like that. So use that to your benefit to make it a little bit easier. We've already done square root of 2 times square root of 2. That was square root of 4. We've done square root of 2 times square root of 7, but now it's minus square root of 14. I do not know what's going on, and how come nobody told me that's not a 7 and that's supposed to be a 4? I'll fix this too while I'm at it. Okay, so that's supposed to be a 4, and that's supposed to be a 14. Then we have to distribute the square root of 7 to both of these. Square root of 7 times square root of 2 is square root of 14, but there's a minus. So minus square root of 14. And then minus square root of 7 times minus square root of 7 is plus square root 49. This is going to simplify almost identical to what it did before, except instead of having a plus 2 square root 14, we're going to have a minus because both of these are subtraction. So this is a 2 minus 2 square root 14 plus 7. The first and the last one were perfect square numbers. So I'd end up with 9 minus 2 square root 14. So this here is what that is equal to. So I have to take both of these, add it together, and they should equal c squared. I'll change the color so hopefully you can see what I'm doing. I'm going to have to sneak it right into the middle here. Hopefully you can read it. This became this. So I've got 9 plus 2 square root 14. This is definitely not going to work, so I'm going to try over. Okay, I'm just going to start on a new slide, and I'm going to transfer some of our information here. So one of them was 9 plus 2 square root 14. So I have 9 plus 2 square root of 14. Remember where that came from was square root of 2 plus square root of 7 squared. I just rewrote it as what we figured out it was. Plus, then we had square root 2 minus square root 7 squared. And what that simplified was exactly this, but with a minus in the middle. So we get 9 minus 2 square root 14. And each of these sides squared added together should equal the hypotenuse squared. So it's going to equal c squared. And if you look real carefully at this, it actually simplifies really nice because 2 square root 14 minus 2 square root 14 is going to cancel. So those are going to go away. All I have is 9 plus 9, which is 18. So 18 is going to equal the hypotenuse squared. You've done this before. You'll have to take the square root to solve it. So c equals the square root of 18. But you have to remember that every answer you have with the radical must be simplified. 18 is not simplified. 18 has the perfect square number 9 in it. So that's 9 times 2. Square root of 9 is 3 square root 2. That is the hypotenuse. And I can hear you in my brain right now saying, do we really have to do one of those problems? It's too difficult. The answer is yes. Yes, you need to do one of these problems. You need to practice them. It doesn't matter that they're difficult. Do them anyways. Okay. Here's your homework, 21 through 29. Do number 63, but don't do part C. So you're only going to do part A and part B on number 63. Okay, well, good luck on your homework. And have a good day.